First, a product introduction, followed by a product demonstration.
I have to know today, are we going to make it or not?
You want the truth?
Yeah, the truth.
Well, it doesn't look good. If we only had some way to figure out what's happening in the old code, we can't get a real feel for what's going on. No, it's all new. They call it Deckfuse. I'm going to see a demo this afternoon. It should allow us to get to all the Unix utilities through Windows. It's faster, easier, and it pulls it all together. It might even be fun.
Well, all I know is that we have to meet the deadline and we have to get it right. If Deckfuse will take us there, let's try it. You broke through?
Only because of Deckfuse. Once we could actually watch the code working, edit, debug, and test were almost painless.
You mean we made this milestone?
On time.
Oh, I knew we would. I knew it all along. You just have to have a little faith.
And Deckfuse.
Deckfuse is a complete integrated programming environment running on Digital's RISC workstations and servers. This is what software development was meant to be: professional, productive, even fun.
In one product, Deckfuse unites well-known Unix commands and utilities, supports standard compliant C, Fortran, and Pascal compilers, and incorporates industry-standard graphical interfaces.
Deckfuse is part of Cohesion, Digital's comprehensive case program. Cohesion offers integrated solutions with which to develop, deploy, and manage software.
Deckfuse simplifies coding, testing, and maintenance.
It opens up new creative opportunities and does away with many of the routine repetitious tasks that used to keep software development teams from ever achieving full productivity. Deckfuse brings increased productivity to application development, it's true, but it has a special impact on application maintenance, where the demand for resources and return on investment continues to escalate. Tom Roberts, Case Marketing Programs Manager, tells us more.
Software is becoming a very significant corporate asset of our customers. A large amount of not just effort, but knowledge of a corporation, of a company, of an organization ends up being in the software. Studies indicate that currently software that is developed will outlive 3, maybe 4 generations of hardware. Not only that, but customers need to develop and support this software over a broad range of computing platforms. What this really means down at a real-world level is that the maintenance of software is becoming a critical part of what our customers need to do. And by maintenance, I don't mean just fixing bugs. I mean, that's always a part of maintenance. You find a problem in software and you need to put in a bug fix. But maintenance also means extending the software. You can go in with a variety of tools within Fuse and rediscover the structure of your software. You can represent it graphically and get a look at it. You can navigate through that software to find out what is where and how it exists. And then when your software engineering team decides that, well, this is how we want to enhance it, or this is how we want to add it or add to it, this is how we want to extend it, they can go into the software and rapidly find those places, navigate through it, make the changes, and go through the edit, test, debug cycle to make sure that the changes really work, and provide that enhanced, extended software in a rapid manner, in a cost-effective manner, and in a high-quality manner.
Deckfuse delivers higher quality in less time because it unifies widely used familiar Unix commands and utilities, including make, DBX, Pixie, and PixStats, and SCCS into a dynamic suite of programming tools. Then it joins them with a state-of-the-art Windows interface in an open yet tightly integrated environment.
How? With Code Manager, providing a graphics-based front end to the Unix source code control system, giving developers the ability to examine and manipulate SCCS libraries.
And Builder, based on the Make utility, provides mouse-sensitive graphical displays of Make files and serves as an aid in compiling and building application software.
The Editor, a mouse-sensitive editor for writing and revising code. Deckfuse also supports Emacs and VI editors. The Deckfuse debugger enhances the Unix DBX debugger with pull-down menus, push-button customizable commands, and a transcript window to trace actions and monitor current events. In addition, there's Call Graph Browser, a powerful visual navigation tool that lets developers see how an application is running, both source and executable files. The cross-referencer accesses the same database and gives the developer the opportunity to locate and classify program elements immediately. To analyze and optimize performance, the Profiler, based on Pixie and PixStats, presents information in a bar chart format so the developer can pinpoint bottlenecks and instantly begin to eliminate them. And always available at the click of a button, online context-sensitive help. At the heart of Deckfuse, the Multicast Message Server, MCMS, provides communication among Deckfuse tools. When any Deckfuse tool sends a message, the MCMS analyzes it and forwards the message and any associated commands to the appropriate tools.
That's how Deckfuse integrates the debugger, Call Graph Browser, Cross-Referencer, Builder, the Editor, Profiler, Code Manager, and Help to create code, analyze it, revise, recompile, and run it interactively. Because Deckfuse coordinates all the communication among tools automatically, the software engineer is free to move instantly from one tool to another, always concentrating on the programming task at hand, not relaying messages between unrelated utilities. The rewards are real, and the personal benefits begin to surface right away. Jackie Kasputis, Deckfuse Engineering Group Manager, has seen what Deckfuse can do.
Based on our experience in the group, I think the three major benefits that Fuse brings to a development organization are, firstly, the ability to visualize your software very quickly, see what the calling structure looks like. You can quickly bring something up and, gee, that's very spaghetti code oriented, or it's really nicely structured. And secondly is the ability to be using the debugger and having the source code window and being able to set breakpoints using the annotation window and that coordination. That debugging interface is a major advantage over what we had before. And thirdly is the ability of the tools themselves to message with one another so that the programmer doesn't manually have to refocus a tool's focus on something. From an intangible standpoint, I definitely think there are benefits. It is more fun to work in a windowing environment and to be able to use the tools graphically. I think it's a lot more pleasant environment than having to look through reams of source code. I've seen people sit down and use it within a matter of 15 minutes there, saying this is great and working with it.
Flexible, portable, and convenient. Deckfuse features create immediate benefits not just for the individual, but for the organization too. Tom Roberts looks at Deckfuse from a practical perspective.
If you want to get down to the real nitty-gritty, if you will, of how Fuse can affect our customers' development of software, you could look at, for instance, the problem of time to market. That is, getting software, high-quality software, out the door on budget and on schedule. One way to look at that is to just look at one very time-consuming part of the software development lifecycle, and that's what we call the edit, test, debug cycle. The customers use a variety of tools in going through that kind of a cycle, and it is very, very time-consuming, especially if the software engineer has to pull out from one tool and get into another. You know, leave the editor and go into the testing environment, and leave that and go into the debugger, and then back around again. Fuse, by bringing all these tools together into one integrated whole, makes it just faster to go through that cycle.
What makes Deckfuse different? Performance, quality, excellence. Chuck Piper, Deckfuse Product Manager, compares the Deckfuse way to the way it always used to be.
Traditionally, software engineers have worked with either individual tools in developing an application or maintaining an application. Now the technology is such that companies like Digital can provide the integration between these tools, and not only provide the integration between the tools, but provide very nice user interface technologies, both in terms of windowing and the graphics content. And Deckfuse embodies all of those characteristics in one product.
Deckfuse. You can see the difference. It takes developers beyond Unix command line interfaces into an environment where they can concentrate on the job at hand, not on how to manipulate the tools they use to get the job done. Deckfuse for Ultrix, the future of application development. Available today at a minimal cost per seat with the maximum return on investment.
The end result of using Deckfuse in a software product is going to be more high-quality software, and that is the ultimate goal of any software engineering organization today. Customers recognize that quality software is the ultimate measure of their job. We can talk a lot in kind of an academic fashion about the cost-effective advantages of Fuse and the productivity advantages of Fuse and how Fuse can help a customer organization produce more high-quality software. But all that is just discussion. To really appreciate Deckfuse and what it can do for a software engineering organization, you've really got to see it.
A Deckfuse product demonstration follows this program. Deckfuse for Ultrix, a truly integrated software development environment that runs on Digital's RISC workstations and servers, and supporting C, Fortran, and Pascal. Deckfuse combines the capabilities of Unix commands and utilities with easy-to-learn, easy-to-use industry-standard graphical interfaces. The result? A suite of programming tools that, working in Unity, bring new creativity and productivity, not only to application development, but to application maintenance as well. It's no exaggeration to say that here at last, with Deckfuse for Ultrix, is programming you can see. What is Deckfuse all about anyway? How does it work? What does it look like? We asked Chuck Piper, product manager for Deckfuse, to give us an overview of the Deckfuse product and its benefits.
The three most important benefits that an organization or a programmer can derive from Deckfuse, the first and foremost has got to be improved programmer productivity. And that is because of the integration of the tools in the environment and therefore the ease of use associated with the environment. I'd say the second benefit is derived from the individual tools themselves, in that we have provided not only a window orientation to the tools, but we have added a substantial amount of value in terms of graphics content. In other words, there's a tremendous improvement in using something like the call graph browser to look at and understand how a program operates, instead of having to go through reams of printout to try to abstract from the output an image of how the application would work. And the third benefit, I would think, is that because the product is based on standards, the software that's developed by the product can be portable over various Unix implementations.
Let's take a closer look at some of the features that make this innovative product so valuable to the professional programmer. The first Deckfuse tool the programmer sees is the control panel. The control panel provides information about the tools in the Deckfuse environment. The control panel allows you to start any tool in the Deckfuse environment. However, you can start tools from any other tool. The control panel provides a window display that tells users what tools are up and running and what files are associated with each tool. Deckfuse tools can be organized into groups. The user populates each group with the tools needed to work on different software modules. That allows developers to work on more than one project at a time, and yet have each group of tools maintain a separate, focused context. Deckfuse, through the multicast message server, keeps track of the tool groups to be sure there isn't any confusion among them. Programmers can work with one group of tools or as many as they want. They can even reassign tools from group to group if the need arises. Next, Chuck shows us the Deckfuse Code Manager and explains its function.
The Deckfuse Code Manager is a motif-based and graphics-based user interface to the SCCS Unix utility, that's the source code control system. It provides for a very convenient manner for navigating through a library of files associated with a particular project. And one of the convenient features about this product is that if it's a maintenance effort, somebody brings some code in from another computer system, from an SCCS library, one of the first things a programmer can do is load the library into the code management system in Fuse to scan it to see what kind of comments are associated with a particular file or a particular revision to a file, see the dates that they were created and so forth. And in fact, the code management system provides access to all standard SCCS commands.
Now, let's take a closer look at the Builder. The Builder provides a graphical user interface to the Ultrix Make utility. Among other things, the Builder provides a way in which to literally see the structure of make files. This graphic can be enlarged, reduced, or repositioned on the screen. If the programmer doesn't like the default screen layout, it can easily be changed to another layout more appropriate for the specific make file. The graphic is mouse-sensitive, allowing programmers to analyze makefile details. To get a better idea of how the Deckfuse tools work together, we asked Chuck to show us how to build a simple application.
The application that we're going to use is a fairly straightforward one, and so in fact it's appropriately named Simple. It's a very straightforward demo. As I said, it's an application that simply prints out the words "Hello there world" with a bunch of exclamation points.
Having invoked the Builder, the Deckfuse interface to the Make utility, Chuck clicks on the desired module to designate the final target. Then he brings up the Deckfuse editor. Chuck knows there is a syntax error in the application. He starts the build process, and the Builder presents a transcript window on the screen. As the program compiles, the error is found in line 59. The Builder issues a command to the system that loads the source code into the editor and flags the error. The error icon, a skull, appears in the line where the error occurs. Moving into the editor, Chuck fixes the syntax error, saves the file, and once again displays the make file in a graphical format. When he restarts the build process, the skull disappears from line 59. It's a clean compile this time. Next, Chuck calls on two more Deckfuse tools, the debugger, based on Unix DBX debugger, and the call graph browser, a powerful visual means of scanning the calling structure of the application, to take a close look at how the simple program is actually running. Chuck describes the debugger for us.
The Deckfuse debugger is based on the DBX debugger, and it provides for very much of a mouse and button-oriented approach to debugging. All of the Unix debugger commands are available, and in fact there is a capability to add or delete or modify the configuration of the buttons that are available for the debugging exercises that a particular programmer would be going through. In addition, if programmers like to use the command line approach to debugging, the command line is available for their use.
The debugger includes a fully functional version of the Fuse editor, though programmers can still use Emacs or VI as their editor of choice. It also includes a transcript window which displays debugging session events. If logic errors cause abnormal program termination, the debugger will focus the Fuse editor display on the line that brought about the termination and flag it with an icon. The programmer can then edit the source code from their Emacs, VI, or Fuse editor, or from the debugger itself. The application can then be rebuilt using the Fuse builder. That's how logic errors can be quickly identified and fixed. In sessions where controlled or scripted debugging is useful, the transcript can be recorded for later use. Chuck invokes the call graph browser from the debugger and sets it up to eavesdrop as the executable code runs. The graphic can be enlarged, reduced, and repositioned on the screen. If the programmer doesn't like the screen layout, it is easily changed with a click of the mouse. He sets the trace switch in the call browser and runs the program once more from the debugger. As each subroutine executes, it's highlighted in the call graph. Now, we can literally watch the program run. That went by a little too fast to really analyze the application, so Chuck decides to set a few breakpoints to get a better view of what's happening. While he's at it, Chuck reconfigures the screen so we can obtain debugger information about the registers, the stack, and the input-output. Then he runs the program again. This time, the program stops at the designated breakpoints. Chuck gets the chance to gather appropriate information. Next, Chuck shows us how Deckfuse integrates the editor and the cross-referencer. The cross-referencer allows a variety of queries: calls, functions, declarations, and references. It displays a summary of each query, followed by the query results. With the editor up, the user can simply click on the answer, and the editor will focus on the specific line associated with a reply. That way, the need for change can be recognized and taken care of without worrying about managing the interaction of the cross-referencer and the editor. Deckfuse does it. Chuck iconifies the cross-referencer and the editor and brings up the last tool he wants us to learn about for now, the profiler.
The Deckfuse profiler is extremely useful for improving the efficiency of an application. The profiler provides timing information about where an application is spending time. It's an excellent tool for identifying application bottlenecks. And not only is it useful in terms of simply identifying those bottlenecks, but the way the data is presented is very nice as well, because it's presented in a bar chart format that is also mouse sensitive. And in fact, what happens is you'll see a bar chart listing of all of the modules within an application and where cycles are spent within a particular module. Then if you want to go investigate down to the line level in a particular module, you just click on that line in the first bar chart, and it will shift to a second bar chart that will deal exclusively with that application module.
Graphic and dynamic, Deckfuse really is intuitive and easy to use. But online context-sensitive help makes it even easier. The information is delivered in a two-part window. The upper window contains specifics about the current query, while the lower one presents related topics. Chuck has given us the chance to learn a little bit more about the Deckfuse tools and to literally see them in action. The Code Manager, the Builder, the Deckfuse Editor. Then we saw integration at work, the call graph browser, the debugger, and the editor. The cross-referencer helps focus on a variety of queries and builds a database about the application file. And the profiler gives the developer visible evidence of performance and points the way to optimization of the code. With Chuck's help, we've just scratched the surface of the Deckfuse story here. There's more. Because it's fully interactive and integrated, Deckfuse eliminates unnecessary steps in both application development and maintenance. Speed, quality, and excellence replace drudgery and repetition. Some people have even told us it's fun. Deckfuse for Ultrix, the integrated software development environment for the professional programmer. You and the rest of your programming team can have it now.